Okay, this video is about end behavior of functions from looking at a graph. So here we have our first function, which is the graph of f of x equals 1/3 x plus 5. So when we talk about end behavior, we're thinking about what happens as x approaches infinity. So what's going on in the graph as we move all the way over to the right? So we are not going to get anywhere near infinity. If you look at my x values here, they're at about 34. If I were to zoom all the way out, I'm still nowhere near infinity, right at the point 29,900. But we can see that as we travel in this direction, as x moves further and further in this direction, our graph is moving up. It might be moving up slowly, but it is moving up. So as x approaches infinity, the function f of x is also approaching infinity. These are called approach statements. And again, at this point, we're only concerned with what we call the end behavior. So what's kind of going on when we put this little arrow at the end of our graph? Where is it headed? Okay, so we're looking at the x coordinate going towards infinity and what happens to the y coordinate or the value of the function as we head in that direction. We can also look at the other direction. So we can look and see what's happening as x approaches negative infinity. So if we were to move in the opposite direction, all the way over, and again, we could zoom all the way out, and we can see that as x gets bigger and bigger and bigger in a negative direction, y also gets bigger and bigger in a negative direction. So as x approaches negative infinity, f of x also approaches negative infinity. Now, this is kind of a boring example because they're both doing the same thing. So let's look at a couple examples where they're doing different things. So in this example, we have what you're used to, a parabola here, and we're going to do the same thing. What happens as x approaches infinity? So it might seem like the function is just going up, but as it goes up, it is moving slightly over here. So if I were to zoom out a little bit, I can see that my x values are increasing as I move to the right. And now if I were to zoom out too much, it's just going to look like it's moving straight up. So I don't want to go too crazy. But this is moving up towards infinity very rapidly. I'm only at 22, 23 here, and look how much it is moving straight up. So one of the things, again, with this arrow that we want to think about, it might look like it's moving straight up, but we're moving a little bit to the right at all times. And every time we move a little to the right, we're continuing to move in an upwards direction. So as x approaches infinity, g of x also approaches infinity. Now, if we look on the left-hand side of the graph over here, we can see that as x approaches negative infinity, so again, while we are on these points here, we are moving more and more and more towards negative infinity, a little bit to the left. And again, we're moving to the left very slowly as we move up very quickly. So in this case, g of x is also approaching infinity as x approaches infinity to the left, as x moves towards negative infinity on the left side of the graph. So on both sides, the end behavior here is approaching positive infinity. Let's look at one more here. So let's look at what would happen in a function like this. And again, let's go home again. So there's all kinds of crazy things happening in the middle here. We can see it's going up here and down here. But again, we are talking about end behavior. So we're not concerned with what's happening in the middle of the graph. We're concerned about what's happening as we go towards the end of the graph, as we move out to the right and out to the left. If we were to zoom out, we can see it starts to really flatten out. As x gets bigger and bigger and bigger, you can see my y coordinate there is at 0.9, 0.975. And if you zoomed out even more, again, we're moving to the right, you can see that's 0.99, 0.996. So this function, and we'll talk about using an equation later, but this function is getting closer and closer. Look, there we go, 0.999, and we're only at 6,000, nowhere near infinity. So in this case, as x approaches infinity, our function h of x approaches 1. So that's kind of a unique situation we haven't seen yet. Let's look at what's happening as x approaches negative infinity. And if you look at our graph here, it's the same in both directions, right? When you zoom all the way out, it almost looks like it's made a T. And we're not concerned with what's happening in the middle. We're concerned with what's happening at the end. So as we move further and further towards negative infinity, at this point, Desmos is just telling us it's 1. Now, we know that there's an asymptote there, so it's not actually 1. It's just that the value of the function is so close to 1 that Desmos has rounded it to 1. So just like it was in a positive direction, as x approaches infinity, negative direction, as x approaches negative infinity, h of x also approaches 1. These are sometimes referred to as approach statements. You can use them for end behavior anytime you has an asymptote. So that's how you find end behavior when looking at a graph.